Hello, 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 friends and neighbors. Welcome to Science. Here we are, Tuesday. It's a big one. We are delving into something unprecedented in this fifth grade life. We are going to be reacting to some reactions. Part one. Here's what you need today. The data table, if you're a taco, was posted on Google Classroom about a half an hour ago. So go ahead and open that while I stall for time. Because it will be very helpful to take notes in it. If you do not have access to that document or you prefer to take notes on paper, I'm going to be putting some data behind me and setting up the data table behind me, but it's a little easier to see if you open the data table that is provided for you. Okay, you can do it in a science notebook or a pencil or on regular paper if you really want to, but again, that's harder to keep track of. And then down here, I can observe a scientific phenomenon. And I can use my prior knowledge of solutions and mixtures to make predictions and inferences. Stay on topic in the chat, please. I see you. So let's go ahead and get started. Our question today is what happens when you mix two different substances with water? In the past, in past investigations, we have been looking at one substance interacting with water and making a solution, or not making a solution in some cases. But we're going to up it a little bit, and now we're not only seeing how these substances interact with water, but how they interact with each other in kind of the medium of water that allows them to mix and mingle a little bit. We're going to be using three different materials. The first one we've used before, okay? This is citric acid. If you remember from our saturating solutions lesson, if you haven't seen that, you can go back there to the past lessons and watch that. Did you know, by the way, that there's a whole live lessons for science playlist that you can watch? You can watch all of the lessons at once. Well, not at the same time, obviously, because that would be hard to follow, but, you know, in order. We use citric acid, and we already saw a couple of things about citric acid that are written behind me. Do they make a solution in water? Does it make a solution in water? Yes. And a couple of things about it. It was very soluble, meaning, I'm going to scoot down here, very soluble, meaning a lot of it can dissolve in water before that solution becomes saturated. That was actually the most soluble of the three substances we observed, more soluble than salt and more soluble than Epsom salt. Okay, and it made those cool kind of, almost like kind of hexagon-looking crystals that we saw. You can go back to past videos to see what those crystals look like of citric acid solution once we evaporated out the water. The other thing that we noticed was that, well, I noticed, and then I told you because you're not here and you can't actually feel it, but citric acid in water was an endothermic reaction, meaning it felt like it was getting colder. And that's going to be important down the line. So endothermic means it feels cold to the touch. Okay. The other two, one of them right here, is baking soda. You might see baking soda in your house. You use it for cooking and baking often. You might also use it, it's a good, it absorbs odors. So often you like open a container of baking soda and stick it in the fridge and gets rid of that stinky fridge smell. And they even make deodorants out of baking soda. Deodorant. It's an amazing invention, especially for fifth graders. The last thing, well, before we get to the last one, I did put together, because we haven't seen it yet, I did put together a solution of baking soda and water. And I added 5 milliliters of baking soda, one of these guys, these scoopies, into 50 milliliters of water. And here is what we came up with. Here's our solution. And one thing you can notice is there is still some undissolved baking soda at the bottom. Let's see if I can tilt it up so you can see the bottom a little better. There's the ceiling, and there's the baking soda, where you can kind of still see that undissolved baking soda there in the bottom. So my first thought was, now, is this even a solution? But then I filtered some out, and yes, it is, because the mass had increased in that same volume, which means there is some leftover baking soda in there. So then I started thinking, well, when have we seen solutions before that still had undissolved solute in it? And it made me think and made me wonder, is this solution, is this already saturated? And is that why there's extra baking soda at the bottom? And so then what you can do to try that is you can add more water. So I'm going to add some more water here. I did not measure it. And I'm going to give it a stir. And the more water we add, then we start to lose a lot of that undissolved. Now you can see how the bottom's kind of transparent because a lot of that undissolved baking soda that was already there dissolved up because we added more water, meaning we made our solution less concentrated and took it below the saturation point. So now, because there's more water, it can dissolve more solute. So one thing we can say about our baking soda is, yes, it does make a solution, and it is not very soluble compared to the other substances we have already investigated. Our salt, our Epsom salt, our citric acid up there. This is the least soluble of those four. The last one, and a very cool one, is calcium chloride. Now, I have this closed for a reason, because calcium chloride is actually a really cool compound. And what it can do is it actually can take, if I were to open this and leave it open, what calcium chloride can actually do is it can actually take moisture out of the air, like, water vapor, evaporated water that's kind of, mixed in with the air, and it can absorb it. It can take in moisture from the air around it. So that's why we're leaving the lid closed until we absolutely need to, because otherwise it's going to absorb a bunch of water from the air. Cool stuff. As you can see, I'll open it just for a little bit so we can observe it. But it is in these little kind of looks like Dippin' Dots, if you've ever eaten Dippin' Dots, but do not eat this. Do not eat this. It literally says, if swallowed, call a poison control center/doctor if you feel unwell. Don't eat calcium chloride. We will not be tasting the science today. I did make a solution with this one. And as you can see, has completely dissolved. Okay. The other thing that was cool about this one, you remember when we were talking about how citric acid is an endothermic reaction? When I mixed calcium chloride with water, it got warm. And that, the opposite of an endothermic reaction, if we think of endo meaning indoor, we can think of exo being outside, meaning it gives off heat. Exothermic feels hot/warm. Okay, so that's kind of our data table so far. Now that we have kind of a sense here of what these three things do by themselves, now let's put them together and watch. And I've got a special treat for us. I have a little bit of a, uh-oh, this was standing up, now it's not. There we go. This here is going to be our observation station. I put it on a black background so we can kind of see what's going on behind and above our reactions. The first one we're going to do is we're going to do citric acid plus calcium chloride. And while I set up the data table behind me here, hold on. If you already have the data table from Google Classroom, great, wonderful. What we're going to do is we're going to have an A, B, and a C. And then we're going to have some observations and some wonderings. I'll show you the data table in a second. I did this out of order. I should have done this before unveiling my observation station, but I was just really excited to unveil my observation station, so I went early. All right, so here is our data table. Okay, just an A, B, and a C. One column is going to be for observations, what you see, what you notice, what you hear maybe. One of them is going to be for wonderings. What do you wonder about? What questions do you have? Okay, A, B, and C, observations, wonderings. Now, back to the investigation. So, we're starting with A, which is citric acid and calcium chloride. You can kind of see it there. There we go. Okay, scoot this back a skosh. The citric acid is already in there. I didn't pour the calcium chloride because, again, I didn't want it to react with the air. We're using 5 milliliters, not milligrams, milliliters of each. We're measuring in volume here. Okay, I'm going to add, again, 50 milliliters of water, and we can watch and observe. And before you do that, make a prediction for yourself. Think about these two substances, right? We have the citric acid, very soluble. Oh, Mars says on the exit ticket, this one's B. Uh-oh. Which one's A, Mars? Whoops. I think I flipped. Did I flip A and B? I might have flipped A and B. Pause, hold, quickly. Sorry, I think I got my letters mixed up. Okay, we're just going to go with this one, and everyone listening, please switch. So the citric acid calcium chloride is letter A, because I don't have the exit ticket right in front of me, and I don't want to waste time pulling it up. So we have 50 milliliters of water with 5 milliliters of, oh, you said A is baking soda and citric acid. Oh, I switched A and B. Okay, we're gonna go with it as is here. Citric acid and calcium chloride is going to be A. Here we go. What has happened? I'm going to give it a stir. Okay. What do you see? What do you notice? Not a very impressive reaction for A. But there is some stuff happening. It's gotten cloudy. Okay. And there are some kind of tiny little bubbles happening. Okay, we're going to let that one, you can see there's a bunch of undissolved calcium chloride down here. We'll let that dissolve. Oh, by the way, for safety, hello. I've got safety goggles on, and I'm masked up because we are dealing with chemicals here. So, safety first. We are going to go to B. B is our citric acid and baking soda. If it says A on your exit ticket, I apologize for misleading you. We're going to call it B. Okay, here is our citric acid and baking soda. I've already got both of them in here because these don't react with the air. So I can pre-fill the two of them. All right, here we go. Getting 50 milliliters of water ready. Get ready. This is baking soda and citric acid, 5 milliliters of each in 50 milliliters of water. Ready? What do you see? What do you notice? We got big time action on this one. We got lots of bubbling. If I lean closer, can you even hear the bubbles? Lots of bubbles. And we've seen bubbles before. Where have we seen bubbles before in past experiments and investigations? What might that be? Really a nice reaction there. I'll put it a little closer to the camera. If you can see the under view, a lot going on with this one. A lot of bubbles. You can see there's bubbles sticking to the side of the cup. Still really, really bubbly. Lots of small bubbles on this one. A mix, actually. There's some big ones, but there's also a lot of small ones. Okay, I'm going to give it a stir. We're going to see what happens when I give it a stir. Hopefully it doesn't explode. It won't. Give it a stir. What do we get? We get lots more bubbles. Right? There's a lot of that undissolved solute sitting at the bottom. So when we stirred it up and got it reacting with each other again, we got another upswing of bubblage here. Now think back, what do you think is causing these bubbles? We say lots of carbon dioxide, perhaps. Good inference. We've seen carbon dioxide make bubbles before. Looks like a carbonated drink. I would definitely agree. I wonder if there's baking soda and or citric acid in a carbonated drink. If you have a carbonated drink in your fridge, you might go look at the ingredients, see if there's any citric acid in there or any baking soda in there.
Good afternoon. Please pardon the interruption. This page is for Miss Felicia or Mr. Orlando. Miss Felicia or Mr. Orlando.
All right, take about 10 more seconds on this one, and then we'll get to our last one, our calcium chloride and our baking soda. This thing is still bubbling away. I'm going to kind of let it bubble off to the side here. Okay, now we are on to letter C. Calcium chloride and baking soda. So we've got our baking soda in here, 5 milliliters. And we're going to add 5 milliliters of calcium chloride. There we are. Let's screw the lid back on here. And we're going to add 50 milliliters of water. All right, here we go. So, letter C. Calcium chloride and baking soda in 50 milliliters of water. Here we go. Whoa, another big reaction. More bubbles, but what do we notice is different about this reaction? I could do this all day. I see the word foamy in the chat. Yeah, I would agree with that. A lot foamier than our baking soda and citric acid reaction. Really interesting. And you can see here, I'll hold it up to the camera. But we can compare the two here. Here's C, and then here's B. Very different in terms of composition. So we can think about what's the same ingredients in these two, and what's similar about the reactions. Then what's different about these two, and what's different about the reactions. That can give us a clue as to what's causing these reactions. We think baking soda might be the one that causes the bubbles. Because it's in both of these and was not in A, right? That did not bubble. And here we've got, this is A at this point. It just kind of looks like water. You can kind of see some interesting, it's almost like, it's tough to see on the camera, but it's almost like they're, like when you put oil and water together, they're not like mixing. Because you can see kind of, I don't know, little wavies going through, which is interesting. And then here, still looking, check that out, still really foamy. I'm going to show you a baking soda to close us out. I'm going to show you a baking soda and calcium chloride reaction that I did this morning and is now sat and has lost all its bubbles. So check this out. Check what gets left behind after this reaction. So here's our clear, and then look at the bottom. There's this layer of white stuff down there. So this is, again, this is reaction C. It's got all this white stuff down here at the bottom. This is our calcium chloride and baking soda as well. But what was left behind is this, I'm going to try and tilt it without spilling solution on my laptop. But you can see what's left behind is this layer of some unknown white substance. Well, unknown to us, white substance. Make an inference, what is this white substance at the bottom? What do you think it could be? Fascinating stuff. All right. Thank you, everybody. I'm going to put all three of our solutions back up here to end us out. Thank you for tuning in, everybody. I do appreciate you being here. You know, this is, again, one of those investigations that if we were in the classroom, it would be that much better. And I'm sad that we're not. But thank you for doing your best with it. So here's our three solutions side by side there. You can see B is still bubbling up, C is still bubbling up, and C is very, very white. All right, make sure your data table gets filled out. Remember, this is just part one. Part two, where we talk about what the heck is actually going on here, that is going to come up on Friday. So come back Friday at 12:30. We're going to briefly recap what we did today, and then we'll get into the why. What is going on here? Okay, so go ahead, use that data table, make some wonderings, ask some questions, make some inferences or predictions about what the heck is going on with all of these substances in water. All right, thank you for tuning in, everybody. Have a wonderful rest of the day, and I will see you soon.